Steady recollection.
That's a lot to ask
He will never be asked to say a prayer again.
for. That was a lot to ask for right there.
That's how you get out of that right there.
I'm not sure that's going to work. Oh, goodness gracious. Well, does anybody want to teach today? I've got some notes here. I got in late. We went to Fort Worth yesterday, and I hand wrote everything, so I'm not sure I can read it.
Driving a car.
There may be a few pauses here and there for me to interpret what I'm trying to say. All right, last week, as you'll remember, we've gotten up through verse 8, and we were talking about time. And we really went over how a day was not necessarily a 24-hour day, but rather a span of time. And the Hebrew word that we used was yom, which could stand for so many different kinds of different time periods. And then we got into, just about how old things actually were and how things were time dated. And we got through the end of the second day, and we talked about how what really should have been worded was there was a beginning and there was an end, and this was a span of time. And instead of saying morning and eve and day, like it was worded. Again, that was for the King James priests and scribes are the ones that interpreted this to English. And Brian, you said something to me after class last week. What was it that Eli? What was it you said that Eli would say? That the priests, they wrote it to please the king, not necessarily
to be accurate,
but to please the King James, who was having it done. So there's some error there in, maybe not error in interpretation, but just intentional interpretation that way to favor the king.
I don't mean to back up too much, but is there any significance to the vault, the separation of the waters at all?
What do you mean?
It says, let there be a vault between the waters to separate the water from the water. So God made a vault, separated the water under, and a vault from the water above. I mean, is there any significance in that? Is it just simply there was water underneath the ground?
Well, there's just water everywhere, and he separated it to be the collect the waters on the earth, as in seas and oceans, and water in the atmosphere.
Okay.
As in fog, clouds.
So we're not talking about under aquifers or water underneath.
No, because at this time there was no land, so there couldn't have been aquifers.
Gotcha. Good point.
Also, the significance of that also is that there had to be a long period of time, probably close to 1 billion years, before the earth was cool enough to hold water. Because you have to remember, the earth was a molten ball of stuff, and there's no way water could cool if it was X number of degrees temperature. So the earth had to cool down enough for the water to collect as the oceans and the seas as. So that's the significance.
So here's the other significant question for me is, Earth has water.
Earth has water.
What other planetary entities do we know of that have water?
We don't know.
Have they found any water on any other planet?
Mars has water.
Well, they don't know. They see evidence of water on Mars. They've actually not found
right?
any
What they call ice
water
caps.
molecules. Huh?
What they call ice caps. But really, they don't know.
They really don't know.
There's some other planets they found in other galaxies that have like their atmospheres look similar to ours.
The only thing that I know of off the top of my head is one of the moons to Jupiter, I believe it is, that they believe is all water ice. And it's about the same size as Earth. And they think that one probably has water. Gosh, it's so far out. I don't know if and when we'll ever discover if it's truly water or not. But right now, I guess the biggest focus of water elsewhere will be on Mars, or the evidence of what was water there. One thing, another significance that you brought that up about water, one, the earth had to be cool enough for the water to be separated into seas and oceans and the atmosphere. But also, as soon as that began to happen, as soon as water pooled on the earth and we had the oceans, then that's when life first started to begin. And it started out as single cell bacteria and algae and things like that. That's when life first started, was after that water pool. So that's what we talked about last week, and that was the end of the second day. So today we're going to start getting into the third day. And if you have your Bibles, you can read with me. We're going to read through verses 9 through 13. And God said, "Let the waters from the heaven be gathered together into one place, and let dry land appear." And it was so. And God called the dry land earth, and gathered together the waters he called seas, and God saw that it was good. And God said, "Let the earth bring forth grass, herb yielding seed, and fruits yielding fruit after its kind, whose seed is upon itself on the earth." And it was so. And the earth brought forth grass, and the herb yielding seed, and after its kind, and the tree yielding fruit, whose seed was of itself after its kind. And God saw that it was good. In the evening and the morning of the third day. All right. Well, we got a lot going on in this third day. There was a lot happening all at one time, and so I'm going to pick out the different sections as we go through this. When you read through that, it doesn't look like much, but when you really dive into it, we have a lot happening here at one time. So the first thing we're going to talk about is in verse 9, that land separated from water. Now you have to realize at this point, well, let me back up just a bit. When the oceans began to pool on the earth and life started as single cell bacteria and algae, that was about 2.5 billion years ago from right now. So that rocked on for a while, and we have evidence of this in, I don't know if y'all have ever seen pictures of this or even know what it is, but have you ever heard of a stromatolite? It's a fossil deposit on the edge of oceans that we see in a lot of places, and it was, we've been able to date that all the way back to the very beginning, and it's where we have a lot of our timeline from, but it's just actually algae and bacteria fossils that grow up in little mushroom type features that look like rocks, and it's called stromatolites. Well, those, before we got land, those moved into multi-cell organisms like amoebas. There's really nothing else in the water at this point but some algae and amoebas. So that rocks along there for about 1 billion years or so. And when we get to the point that land starts to appear, we're at 440 million years. So we've burned through about 4 billion years of time to get to the point where land never shows up on Earth. So we have we have a soft, molten lava Earth. It finally cools down to get water on it. Once it's cooled and life starts growing there, then God gives us land at that point, which we see in verse 9. What was this landmass called? Do y'all remember this from high school?
Pangea?
Pangea. Yeah. Way to go, Troy. What was Gondwana land?
That was after it started breaking apart.
Okay, here's a dumb question.
What?
I'm full of them.
No, you're not.
So, how did Pangea get there? Volcanoes?
Well, we think so. That's a good point. It's a really good point. I was going to bring that up. We really don't know. The most logical thing in what we can see from the rocks is that not necessarily, yes, volcanoes, but like all at once. Like
Was there some reaction or something?
no, the crust just got thin, and you know, the mantle of the earth is like the skin on an onion. I mean, really and truly, it's only like 80 miles thick. And then underneath that is just molten lava. So
the crust of the earth?
The crust of the earth.
It's a mantle.
Well, the crust and the mantle together. The hard part.
Together they're 80 miles?
It's about 80 to 120 miles thick, depending on where you're
Stuff
at.
starts pushing up.
So what happened, we had a thinning spot on the surface of the earth, and all that magma and lava came up at one time and created this huge landmass. Think of it kind of like maybe like a pimple on a big ball or a big bulge on a tire or something like that. It just rose up out of the water, all in one land mass that covered. And you remember what Pangea looked like? It was kind of ovalish, more or less. And a couple of neat things about Pangea. First of all, you have to remember it most likely was, I'm going to say 90 to close to 100% chance that that's what it was. It was all volcanics that came up. So it had to have a long time to cool itself from being a molten rock that made it to surface.
Where was that, the central location of Pangea? Was it as far as latitude wise? In the middle?
Yes, and I'm going to talk about
Okay.
that too. So Pangea had to cool off before anything happened. So where was it located? Like he just asked, it was located on the equator. It wasn't north and south, it was oblong, pretty much located on the equator of the Earth. So all of this attributed to a very hot, humid climate. You had the heat from being on the equator, which is the hottest part of where you can be, and then you also had the heat from it being all volcanic rock, and it had to have time to cool itself. Did that answer your
Yeah,
your
so that,
question?
and that's where the vegetation stuff, and now you're probably getting ahead.
That's where
That's how the vegetation.
Exactly.
I
Had
keep
it been
thinking-
on-
I keep thinking of it being more elongated, but you're
No,
right.
it's
It had-
actually
it had to be-
horizontally located on the equator, all on one
in
side of the planet.
Between the tropics, pretty much.
Yeah. So it was a very tropic environment, you know, humid, very hot,
A lot of rain.
well, we didn't have
We had
rain
rain back
yet.
then,
We
okay.
didn't have rain yet, we just had fog, so to speak, but it was a very clammy climate, humid, that was, you know, be hard for us to live in or take much of it.
So is the
You know,
assumption-
Temperatures are probably 120 degrees.
I'm talking about that.
And I'm thinking inertia and spinning, so at this point, the assumption is the Earth is already in its rotation.
No, the Earth is not spinning yet.
Okay,
The Earth is not spinning yet. The Earth is,
because we haven't had day and night,
we haven't had day and night until we get to verse 14.
okay?
So we have Pangea all located on the equator on one side of the planet.
Assuming it's facing the sun.
And it is facing the sun because we know we have continual sunlight. Right. Plants start growing on this after it starts cooling down. Excellent.
And if there's
question.
daylight all day long, they're growing. There's no
Exactly,
stopping.
exactly. And like I mentioned to you guys before, and when I'm gonna go into this a bit more,
Wait, do we have light? We have light already, right?
we have what?
We have light?
Yes, we have light.
Okay, we have light.
We have light. We got that back in verse 2.
We just don't
But it's a
have day.
continual
We
light.
don't, but we don't have day and night.
We don't have day and night yet. We have a continual light, and that makes sense. If you remember Pangea's all on one spot, on the planet, on the equator, and it's, I'm assuming that it's rotating around the sun, but the Earth is not spinning yet, and we don't have a moon just yet either, you know. So everything is continuously growing. Like I told you early on, is that the trees that we have found from that time period don't have growth rings. So we know that there was not seasons, there was not day and night, there was not a stop in the growth. It was a continual growth, continuously.
Well, there's still trees that are around.
Yes, we still have
now-
some fossils.
Oh,
Fossils?
fossils, okay.
Yeah,
okay.
no,
That
not
makes sense.
trees, no.
Yeah, yeah.
Just the fossils from them.
Yes, Troy, there are 2 billion-year-old trees.
Unbelievable. I wanted to
That's
see
pretty
it.
old. Let's head out to Yosemite and see those
Okay,
things.
now I have a question. I'm kind of confused on this landmass. We had an earth that was covered with water,
Yes.
and then part of that water got divided into the sky and part of it stayed here. Do you think that drew some water off the earth, and that's how
Well, let's
the,
back up.
that's how the land?
So we have
came?
this round hot ball, and we got all this, gosh, you know, our words don't exactly describe what I'm trying to say. We have this hot ball, and we have the humidity and we have the water in the atmosphere that surrounds the earth. Once it cooled enough, then God placed it on the earth and it pooled as in oceans and seas. And then we have the atmosphere, which is nothing at this point but dense fog and clouds. We don't have rain yet. So then the earth's crust thins and we have this bulge and explosion of magma and lava that came to the surface underneath the water, out of the water, and created a landmass outside of the water.
Okay.
And it's all one big land mass of all the land that we have on Earth now. But it was all conjoined together as in one land mass called Pangaea. And it hovered, elongated-wise, at the equator on an Earth that is not spinning yet, but has continual sunlight because it's most likely pointing towards the sun as it rotates all the way around. Even if it is rotating, we don't know, but we think. You know, it could just be still and pointing at the sun, Pangaea, but even if it isn't or isn't circulating, we have continual sunlight yet. So we don't have rain yet, we don't have day and night yet. Does that make sense?
Okay. Yep. I got it.
Sure.
I got it.
Okay.
I could do it.
So
I want to record some of the questions we all have. I think that's
So when you go back into the fossil record, we find the very first plants on Earth, and he calls it Earth, so I'm going to call it Earth, Pangaea. The very first plants that we see occurred 440 million years ago. Earth is only 4.8 billion years ago, so you have to see that we have burned through 4.4 billion years to get to the point where we just now have land and we are just now seeing some plants.
Are the plants that they found older than the amoebas that they found?
No, they're younger.
They're younger.
Yeah. This is the first thing we see on land. We've already had things in the water starting to grow at this
Okay.
point.
'Cause we
We've
haven't
got some
got
things
there
happening
yet.
in the water, but we don't have things happening on
Did they have trout?
no trout yet.
No trout,
Maybe some
okay.
trout bait. Maybe some bait, but not the actual trout.
Randy said there are no dumb questions.
No, there's
I
not.
appreciated that question.
Thank you.
Oh, I'm trying to read my writing. Hang on a second.
Do they have like a visualize what the landmass looks like of Pangaea?
Do we?
I mean, like, cause I'm looking
Yes,
at
if Brian would
pictures.
get me a whiteboard in here, I could draw you pictures and stuff, but.
Cause you said it's elongated on the equator, but pictures I'm looking at, it looks like it's cut in half by the equator.
Yeah, but
Let me see what you're looking
centered
at.
around.
So you had you still had a north of the equator and a south of the
It's
equator.
So much like
G-A-E-A. P-A-N-G-A-E-A.
So that's why it's
Hi, baby. Oh, what you doing? You see those knives?
So I'm just thinking out loud, if you've got a chunk of land,
The one that I
or you have
saw
if you have the side of Earth facing the sun all the time, you got to think about the temperature
Giving it
difference
some
between both
side-eye.
of those sides.
Yeah.
So if there's continuous sunlight, then you would have had continual evaporation taking place. So the water
Yes.
in that area would be continually being pulled into the atmosphere. So you had the reduction of the water surface. Now I'm just guessing here. And then with the continual heat being shown on that part of the Earth,
Right?
there could have been a quicker drying or a quicker
Hmm?
cooling, as it were, of that portion of the body of the planet in such a way that it caused whatever was underneath to go, hey, it's thinner over here, I'm gonna, because it's always wanting to poke out, right? I mean, the mammal is always trying to find
Yes.
a place to get out, because it's hot, it's trying to get,
Yes.
it's trying to release, and so
Yes.
that would make, at least in some regard, some sense of why it would have happened the way that you're describing it.
Right. Her pictures of Pangaea, you know, I think it's, we don't know. It was an artist's rendition of what she showed there. From my geology books and what I went through, it was more of an elongated piece like this TV here. And what she's showing is that it was up like that because that's the way our continents are kind of oriented now. So I think that, you know, if you, I guess if you really didn't know, that's kind of how you would see it as more of a
north-south,
Yeah,
as opposed to east-west.
situated like that instead of sideways along the equator, more of like this. But I think it was more like this, especially in the beginning. Of course, it all rotated and turned and all that. And we're going to get into plate tectonics and all with that. But I think the first one was like that because when you put all that land back together, and I'm getting ahead of myself just a little bit, and there's a band across all the land where all the dinosaurs and plants and all that grew, it was across a horizontal part of all the land. So when you put it back together, you can kind of see where that area was that was had the most growth of plants and animals and stuff like that before it started shifting north-south and then breaking apart and going itself around the earth. Man, y'all asked all the right questions today. That's exactly what.
Except the trout question.
Except the trout. The trout caught me off guard. All right. So we read in starting in verse 11. God said, let the earth bring forth grass and a herb and a fruit tree. That's what we started talking about now. Well, so soon after land comes about, and before it all breaks apart, it has to cool down. And once it's cooled down, then plants start growing on earth itself. And the first thing that starts growing, he calls tender grass, and the Hebrew word of it is ditch, D-E-C-H-E. And what that word actually means in Hebrew is, it says tender grass here, but what it actually means is things like lichen and moss and algae, things that you've all done this, you've all been in the forest, you've all been in places where there's nothing but kind of rocks, but you can always see that there's some lichen or moss or something growing, even when there is no anything else growing around, just on bare rocks. So that was the very first thing that started, was lichen. That was the tender grass, the moss, things like that.
So, Pangea. Was there mountains in Pangea?
I'm sure there were.
Okay, so it wasn't just a
Solid flat
relatively
land.
flat. Yeah.
Who knows?
Okay.
You come from a
I would think it would be like
Yeah.
this. I can't imagine it just being perfectly flat.
Yeah.
You know how high they might have been, probably not very high, but still there was highs and lows. I don't know if, that's a really good question.
Right?
But you're not talking.
Yeah, see?
I'm not
Probably
talking
not.
like
Probably
Rocky,
not yet. There was nothing that was 15.
We're not talking the Himalayas.
no, we're not
the
talking
hill
Rocky
country.
Mountains or something like that. We're talking about foothills
Yeah.
type
Yeah.
elevation changes. Maybe of 1,000 feet, but not 15,000, something like that.
Had some trails on
So after some time passes
They didn't have toes.
in the tender grass and
How about trout again?
Dinosaurs, they had toes.
They can't climb mountains so they didn't have toes. Not toes.
Way off.
toes.
On the side of a mountain.
it. This might be a
No,
12-week
they're
study.
like, look.
We need a remedial class. You need to give this version and then a remedial
Yeah, no
version in a different room somewhere.
After the tender grass, next came what he refers to as an herb yielding seed. Well, what is that? The word in Hebrew is eseb, E-S-E-B. And what that turns out to be is things like ferns, spores, things like mushrooms that produce spores, and ferns that propagate itself underneath the ground. You know, it just grows by a root system and pops out. That's how things were propagated next. So you go from the lichen and the moss, then you get into the ferns, mushrooms, and things like that grew along the ground that didn't have to. After that, then came the trees, fruit trees, things that yielded a seed, a hard seed case.
But there's still no water, right?
There's no rain.
No rain. So how do these?
There's humidity.
There's tremendous humidity.
That's
It's
how they
just
grew.
Like
it was probably so foggy, Troy, you could probably barely see the church. from here.
So that's how they grew the.
Yeah, it's just the air itself, condensated on the leaves, dropped in, and that's how it watered itself. But we did not have clouds that rained. But just like in a rainforest, the humidity is so much that the dew and stuff collects on the leaves, drips down, and waters the
I'm
plants
still
down.
picturing like rivers and stuff, right?
Pardon?
I'm still picturing like rivers and
Not yet.
Right.
No water.
Not yet.
not,
Not yet.
Pangea would have been a dry,
Pangea was a dry, one-unit mass.
but it would have been kept damp. Would have been like a sponge, a moist area because you would have.
Yeah, and that's what I was just telling Troy. It was like a rainforest. It was just tremendously humid. Like I said, you could probably not see very far. There's dense vegetation, and it was also a dense atmosphere with no rain, and that's how it rains itself. So thirdly, the last thing that come out was the fruit trees. And so we're talking about things like apple trees, pear trees, oranges, lemons, things like that. So why did the plants grow in this order? Why these plants and why in that order? Well, if you go back and look at the soil, you have to think back. Okay, lichens and moss, they'll grow on anything. They'll grow on hard rock. And the next thing that comes along is ferns and mushrooms, stuff like that. Well, what do they take? Well, it just probably only takes about an inch of soil for something like that to grow. So in the very beginning, there was no dirt. There's no soil. Everything is just solid rock.
Yeah.
Solid rock. So that's how the lichen and stuff grew. So after there's some erosion, some time passes, dead plant material from the lichen and the moss and whatnot, we start getting a little bit of soil. And so that's how the ferns and those mushrooms and stuff like that start growing.
What caused the erosion so there's no rain in the river?
He didn't mean to say erosion.
What caused,
He didn't mean to say erosion.
Well,
That's not what he meant to say.
there could be some wind erosion.
Weathering.
But weathering, just things.
Like decomposition.
Yes, decomposition of the lichen and the moss and the thing, and the rocks itself. I mean, everything just decomposes itself as it lives. And so then thirdly, all these things grow for millions of years before there's enough soil everywhere for the trees to grow. Because you have to have a substantial amount of soil before an actual tree will grow that can grow fruit. So you can see the beautiful order that God put this in. You know how you start with the land itself and no soil to a little bit of soil to more soil and how these things develop.
So is soil just ground up rock?
Soil is about, well, it depends on where you're at, but it's about 50% organic matter, dead plants and
That would account for the mosses and stuff.
yes,
decomposing.
and the other is just weathered rock. Just crushed
But
down to the point where it's,
Doesn't lichen, like the roots go down and split the rock and make it decompose quicker?
yes.
So you got both of those working at the same
Yes,
time.
yes.
The lichen dies, but
Yes.
it also.
Roots are breaking apart the rocks, and then all that goes to start creating soil. Yes.
Was there wind?
That same
Same brain.
same brain. That's what I was raising my hand
Is
to
there
say.
wind? We really don't know what the weather patterns were either any more than
Because I'm
other than-
thinking like, okay, so at some point in time, the Earth has to start. Like I am envisioning that as our atmosphere is developing, that eventually our Earth is going to start spinning, and then right now is the Earth. At some point in time, we're gonna.
I think it's probably already cockeyed.
Okay.
A little bit.
Is maybe because of the
But I don't-
Pangea?
But I don't think that we're not spinning it. I
Okay.
know that for a fact. If we're not spinning, we probably don't have wind.
Right.
Because the spin is what creates our weather and the wind. If the Earth stopped, everything would become, yes.
seems like it was when the day and night, when they established that, because that was the ocean, that's being able to pull
Yes,
waves
and
out,
the
pull
moon,
waves
and the
in.
moon for the tides and those
Point.
kind
So is
of
there a
things.
moon yet?
There's no moon yet.
How do you know
Continual
it's not on the
sunlight.
backside?
Pardon?
How do you know it's not on the
There's
backside?
a song about that.
Because the Earth's
Because he
not
doesn't
turning
say
it.
so until the next few verses.
Oh, that's right.
Wait, wasn't the
At this
moon?
point, the
Isn't the
Earth is
moon
outside.
part of the Earth that?
Well, the theory is that there was two planets that hit each other. We absorbed a lot of the rock from what hit us, which made our Earth bigger, and made the moon smaller. So the moon is the result of the second planting hitting us, and it's what's left that chunked it out there away from us, but we have enough gravitational pull that it keeps it locked onto us.
But you said we don't know the weather patterns?
We don't know the weather patterns because the Earth wasn't spinning, so we don't
We
know if
can't
there was
know the
any
weather
But
wind.
how do they know we're warmer now than we were then?
We're not warmer now than we were.
Because.
Don't get him started on that.
He knows what he's doing. He knew right where he was going with that. It's almost time to quit, so let me say this right quick. So at this point where we've got trees growing, it's 360 million years. And we know that for a fact.
Now wait, that's
When did we
from
start?
4
Wait,
point-
when did we start? When was Pangea? 4 billion?
440 million.
Now,
We started out at 4 billion.
9 billion.
The
How
Earth,
long did it take from
Got-
Pangea till you get trees?
yeah, that's your
Approximate,
question.
approximate.
said 100.
80 million years.
80 million.
About 80 million.
That's a lot of decomposition.
It's a lot.
I mean, those numbers are so hard to wrap your mind around, you know? It really
I
is.
think we're beating Randy down with dumb questions.
No, you're not. I love it. Please continue on. Please
With
ask
Brian's
this.
questions.
All right.
I just don't understand global warming. That's my key now.
Shuddy. Shuddy.
All right.
He's a troll.
All right. Soon after, and I'm gonna hit on this more next week, but I'm gonna end on this.
Before global warming or not?
Soon after the trees got here, and all that was established, soon thereafter, Pangea started breaking up, and we had plate tectonics, and I'm gonna go into that while we had plate tectonics, but you know, if you go into the next verses, in verse 14, we stopped at 13, which is the end of the third day. The next verse talks about day and night. We establish a moon, and we have a daytime and a nighttime. Well, that's when the Earth started rotating there. And we'll talk more about this, like I said. And Pangea started going, breaking apart and not only going sideways, but also north and south. So that you have land masses north and south, you can start having temperature changes and for a seasonal change. Also, you have land masses on opposite sides of the Earth. Well, the only way that this side could get sun is if the Earth starts spinning. So the Earth starts spinning so it can all be introduced to light at an equal amount
Did it
of
start
time.
breaking apart because of day and night? Or
Yeah, because the spinning would push the land apart.
Well, it
Centrifugal
had-
force, it would go.
Then we'd still be pushing away.
Well,
Are you saying it's
what causes it to
No,
break
not
apart?
really.
Just
what causes break apart is the heat of the Earth.
pressure?
The heat of the Earth causes cracks all the way around, which we know is plate tectonics. And as it heated, you created continental drift. We're just floating on top of this bed of hot lava. And anytime you put something on, we'll just put something on top of a pot of water and watch it. You can put it there together, but it'll eventually float.
So
apart
the
from
land
each other.
masses, the continents are not floating.
Yeah, we are floating on top of magma, and the reason is that underneath we have this big, extremely hot furnace ball of magma that's, this heat is going like this, rising. And when it does like that, it's pushing the stuff on the surface around. It's hard to do that with my hand without being able to.
So when we're talking about plates,
plates,
each
there,
continent doesn't have a plate. There's tons of
almost
plates.
every continent has a plate.
Okay, but there's other plates that are in the ocean.
Yes. Yes, there
That's what
is.
it means.
But a lot of the plates that are in the ocean are also connected to the land mass as well. It's not neatly around the continent
Not the
edge,
east on the
Yes.
plate.
and it's not around the edges of the water.
They're all.
It's all in. I wish I had a picture to show you.
Brian's gonna get him a whiteboard next week.
Yes,
Hey,
Brian.
if
give
you
them a
will get
whiteboard.
an iPad, you can do pictures on the TV screen.
What do you want me to freehand draw?
Oh, okay. I'll get you a whiteboard.
So you'll really understand.
I'll get you a whiteboard, but you can do like a PowerPoint.
We're gonna talk more about that next week.
Anyway, we're gonna talk more about all that next week.
That gives
That's
your
it.
pastime.
This is
We're
going to
done.
turn into
So
my
wait,